Welcome to my channel, dear students and all the viewers. Here is the problem of GP series, and now it is related to a question, that is geometric mean. The two numbers a and b are given. Now find the sum of the nth geometric mean between a and b. See, here is the question is that, again I repeat the question here, find the sum of the nth geometric mean between a and b, and that is your sum. Okay, so see, a and b are the two numbers. Here the GP series after a, it will be a ar square, like that. So the last mean here is a into r to the power n, and this is b. Actually, how it possible this is the last term is this? So here is the nth arithmetic mean and include a and b. So from our GP series, the total number of term of the GP series be here n plus 2. Okay, so this is the nth mean in between them. We have to find the value of this sum. The total number of term be here n plus 2. Let r be the common ratio, that's why the series is this. So this is the last term, and b is the nth plus 2h term. So t n plus 2h term is equal to a into r to the power, that is the number of term is n plus 2 minus 1. So a into r to the power n plus 1. If this is b here, b, as b is this, so the term is a into r to the power n plus 1. So previous term is divided by r, then it would be a into r to the power n. Actually this is the last mean of this series. So from that is this b is equal to a into r to the power n plus 1. So this is b by a, and this is equal to r to the power n plus 1. So this is the value of r is b by a root of n plus 1, and this is b by a and whole to the power 1 by n plus 1. Okay, 1 by n plus 1, and this is the sum of the mean of this series. The sum of the series, first term is here a. Now we have to find the sum of the mean. So for this mean, first term here is ar, not a to b here is the n plus 2h term. Only question is that the sum of the geometric mean, not from a here, from ar. In that case, ar be the first term of the this progression of the sum of the mean. Okay, first term is ar and ratio be here r. So number of term of this mean is here n. So r to the power n minus 1 by r minus 1. Now put r is equal to b by a whole to the power 1 by n plus 1. So put here r and these are. So we got this, and now take LCM. This is by a divided by a. So b to the power 1 by n plus 1 and a to the power 1 by n plus 1. So the LCM value is a to the power 1 by n multiplied by, and this is a to the power 1 by n, and a is this, b by a whole to the power this, and this also b by a whole to the power n by n plus 1 is this. Okay, now simplify a to the power 1. This is from here, b to the power, actually b by a whole to the power 1 by n plus 1. So we can write here b to the power 1 by n plus 1 and a to the power 1 by n plus 1, and here is a to the power 1 by n plus 1. So write here a to the power 1 by n plus 1. So these two figure are cancelled, and within the bracket if we take LCM a to the power n by n plus 1, so the LCM value is a to the power n by n plus 1, and b to the power within the second bracket the value is b to the power n by n plus 1 minus a to the power n by n plus 1. If we take the LCM of this figure, a to the power n by n plus 1, so within the first bracket, that is b to the power n by n plus 1, and multiply by 1 a to the power n by n plus 1, and this is the figure. Okay, now these two figure are cancelled. So a left here is a to the power 1, b to the power 1 by n plus 1 within the bracket, and this is okay. Now from a to the power n by n plus 1 and a to the power 1. So indices, from indices doing a minus a to the power 1 minus n by n plus 1. Okay, and write this, and b to the power 1 by n plus 1, and here is b to the power 1 by n plus 1 within the bracket. The figure is this, and this figure is okay, and this is here a to the power 1 by n plus 1 multiply a to the power 1 by n plus b to the power 1 by n plus 1 by n plus 1 to the within the first bracket, multiply these two terms. Okay, so we got this, and divided by b to the power 1 by n plus 1, a to the power 1 by n plus 1. So if we add these two, this is b to the power base are same. So you add these two, b to the power 1 by n plus 1, b to the power n by n plus 1. So the power of b here is 1. Okay, b here is 1. Same as if add the power of a to the power 1 by n plus 1 and a to the power b by, sorry, this is n by n plus 1. So the power of a here is, indices here is 1. Okay. So this is, and take common minus 1. So this is a into b to the power 1 by n plus 1 is this, and minus b into a to the power 1 by n plus 1 this is, and take common again minus from this numerator and denominator part. So cancel this 2 minus, we got the answer. Okay. Match this figure with this. Okay. Thank you.